Let's have a look at this one. A spring is extended 8 millimeters by a force of 1.5 newtons. What is the spring constant? The force constant, the spring constant, yeah. So what you have here, you have a spring. I'll just draw what you have. The K, yeah. And then we move this out a distance of 8 millimeters. And when we move it out a distance of 8 millimeters, there'll be a force going this way. And we move it out with a force going this way. And they cancel so it doesn't move. So like we pull it out and hold it. This force on the left we do know. What's the name of this force here? This is the force you get from Hooke's law, which is K delta X, or X, or whatever letter you want. And they tell us that that equals F, which is, 1.5. So you have K delta X equals 1.5. But you know what the delta X is. What's the delta X? It's 8 millimeters, yeah. So you get K equals 1.5 over 8 times 10 to the minus 3. So this will be a pretty big number. 1.5 over, yeah? 187. That's pretty big. So it's still, yeah, we'll keep it as that. What's the unit for spring constant? Newton per meters. Okay? Was that part okay, Louise, or that part was difficult?
I think in the B, this one is okay.
The B part, yeah.
Because I checked the look and I can do that. And then the B part, I said something that I forget.
Yeah, B part's a little tricky. In the B part here, the spring is then fastened to a horizontal surface and a mass of 0.6 is attached. That's 0.6 kilograms. The mass is pulled 4 millimeters. So the mass is pulled 4 millimeters and then it is released. So what happens here is, well, you can imagine this. If I pull this out to here and let go, what will happen? It'll go back and forth, yeah. So it's going like this. Release, let go. Can you see that this distance here is also going to be 4 millimeters? It's going back and forth. Now the question is, what is the period? Now we know the formula, it's 2 pi over omega. The problem here is, what is the omega? Now there's a formula, Louise, there's a formula in the formula book for when you're talking about springs. And I always have to check it because I forget it. It has a K, an M and a root in it. I'll just confirm it. The formula is, yeah, so I always muddle it up. Is it K over M or M over K? You think so? I think so too. That's for the time. Oh, yeah. In fact, they give us the formula directly. The time is 2 pi root M over K. This is for when you have a spring. So we know all these numbers, don't we? What did I get for the K? It was 187.5. .355 seconds. Yep. Now the next part is they want to know the maximum velocity. So we have V max equals A omega. Do we know the A? What's the A here, the big A? 4 millimeters. That's the A. No, you see, the amplitude is always just like this, A and then minus A. Not 8, yeah. The problem is, we know this, but we don't know this. But we can use the formula T equals 2 pi over omega. So omega equals 2 pi over T, because we know the T. So if I just put that back in, I get V max equals A times 2 pi over T, which here would be 4 times 10 to the minus 3, 2 pi over 0.355.
0.7.
Okay.
0.07.
0.0708 meters per second. Or if you want, you can write that as maybe 7.08 centimeters per second. Might be more appropriate. And that's A2.